Hello friends, welcome to our YouTube channel SRK Pune Academy, whose tagline is Made Simple. In our world-class manufacturing system, today we will see topic number 5, that is SMED, means Single Minute Exchange of Die. In world-class manufacturing system, till now we have completed 4 topics, whose links are given in the description below. In the upcoming videos, we will complete all the remaining topics. So please stay with the channel, subscribe to the channel and watch the video till the end so that you will become an expert in world-class manufacturing system. In this presentation, we will study topic number 5, that is SMED. After completing of this presentation, we will able to understand what is SMED, basics of SMED, history of SMED, why use SMED, basic steps to reduce changeover, implementation, SMED process and benefits. Let's start from what is SMED. SMED means Single Minute Exchange of Die is one of the many lean production methods for reducing waste in a manufacturing process. It provides a rapid and efficient way of converting a manufacturing process from running the current product to running the next product. This rapid changeover is key to reducing production lot sizes and thereby improving flow. The phrase single minute does not mean that all changeovers and startups should take only 1 minute, but that they should take less than 10 minutes. In other words, it is single-digit minute. SMED is a concept to reduce changeover time. Means minimize the time lost in changing over from one size to another, or one product to another, or one service type to another. A die is a tool used in manufacturing. However, SMED's utility is not only limited to manufacturing. Now basics of SMED. In SMED, changeovers are made up of steps that are termed elements. There are 2 types of elements. 1. Internal elements means elements that must be completed while the equipment is stopped. 2. External elements means elements that can be completed while the equipment is running. The SMED process focuses on making as many elements as possible external and simplifying and streamlining all elements. Before SMED, all changeover elements are performed while the equipment is stopped. These are referred to as internal elements, which is shown in blue. Streamline elements identify elements that can be performed while the equipment is running and make them external to the changeover, which is shown in red. Convert elements, review remaining internal elements, and ask what it would take to make them external. Convert as many as possible to external. Streamline elements, review all elements for streamlining and simplification. This shortens both changeover time and external time. Now we will see the history of SMED. It is developed by Dr. Shigeo Shingo over a period of almost 20 years. The development involved intensive study and improvement of setup operations in many factories and industries, facilitated by the recognition that setup operations can be categorized in internal setup, machine must stop to perform the operation, and second, external setup, machine can be kept running whilst operations performed. SMED aims to minimize internal setup time. Dr. Shigeo Shingo is known as the father of SMED. Now, why use SMED? As we know, the lean principles are 1. Define value from the customer's perspective. 2. Identify the value stream needed to go from customer request to requirement delivered. 3. Ensure the product flows through the value stream without delays. 4. Use pull scheduling so that product is made only when the customer wants it, just in time. 5. Strive continuously to eliminate waste from processes. 6. Uses of SMED. SMED is used for 1. Large lot production waste. Large batches are produced to reduce the number of changeovers as setup times are usually long, leading to overproduction and excess inventory, waiting time, defects and transport or motion. 2. Changing customer needs. Customers are seeking an ever-increasing variety of products that are available when they want them. Product life cycles are being compressed as innovation becomes a key. Shorter timescales are required to facilitate these needs in both the design development cycle and in production. 3. The concept of time. From a logistical standpoint, a company looks to deliver on time in full to customers. Economically, it is advantageous if process lead time is short. Many time-consuming activities, however, do not add. Now we will understand basic steps to reduce changeover. Step 1. Observe the current methodology. 2. Separate the internal and external activities. 3. Convert internal activities into external ones. 4. Streamline the remaining internal activities by simplifying them. 5. Streamline the external activities so that they are of a similar scale to the internal ones. 6. Document the new procedure and actions that are yet to be completed. 7. Do it all again. For each repetition of the above process, a 45% improvement in setup times should be expected, so it may take several repetitions to cross the 10-minute line. Now we will see implementation of SMED. Shigeo Shingo recognizes 8 techniques that should be considered in implementing SMED. 1. Separate internal from external setup operations. 2. Convert internal to external setup. 3. Standardize function, not shape. 4. Use functional clamps or eliminate fasteners altogether. 5. Use intermediate jigs. 6. Adopt parallel operations. 7. Eliminate adjustments. 8. Mechanization. External setup can be done without the line being stopped, whereas internal setup requires that the line be stopped. He suggests that SMED improvement should pass through 4 conceptual stages. Stage 1. Ensure that external setup actions are performed while the machine is still running. 2. Separate external and internal setup actions, ensure that the parts all function and implement efficient ways of transporting the die and other parts. 3. Convert internal setup actions to external. And 4. Improve all setup actions. Now we will understand SMED process. It mainly works in 4 stages. 1. Preliminary, no differentiation between internal and external setup operations. 2. Stage 1 internal and external setup operations are separated. 3. Staged internal are converted to external if possible. 4. Stage 3 setup operations are streamlined, internal first. Now let us take an example of setup on a machine to understand these stages. The table shows the setup activity details of a machine. Production of 2 parts are done on this machine. After completion of production of 1 part, the setting of the other part is done. There are total 15 activities, and shown the time required for each activity. It takes 69 minutes to complete this setup. In this stage, internal and external setup operations are separated. Activities that can be completed while the equipment is running are separated. Now total setup time 69 minutes is separated into categories. Internal setup time, which is 48 minutes, and external setup time 21 minutes. Now we have to focus on internal setup time reduction to achieve our target of single-digit minute. Now we will understand an example to reduce setup time activities. 1. Both the fixtures mounted on machine table and all required tools loaded on tool magazine of the machine. 2. Inspection time reduction, attribute type gauge made to check all holes position to eliminate CMM machine inspection waiting time. After completion of improvement activities, it is clear from the table that 48-minute setup time is reduced to 7 minutes. We can see total 8 activities are eliminated due to improvement done. In this way, we can able to reduce setup time 69 minutes to finally 7 minutes by following the SMED process steps. Now finally, we will go through benefits of SMED. 1. Flexibility without the need to hold stock. 2. Quicker delivery, reduced lead time and customer waiting. 3. Improved quality, less storage-related defects. 4. Greater equipment productivity, shorter downtime and changeovers, linked with OEE, overall equipment effectiveness. 5. Smoother startups, standardized changeover processes, improve consistency and quality. 6. Lower manufacturing cost, faster changeovers mean less equipment downtime. 7. Lower inventory levels, smaller lot sizes result in lower inventory levels. Thank you for watching and understanding presentation. To get such important presentations, subscribe to the channel and like the video. Do comment and let us know how you like this video. Our next video will be on Kanban. Thank you very much.